because you are getting xk, where k is the discrete frequency. So now these are the discrete frequency, but these frequencies should correspond to what hertz? How you know? I will tell you. But this frequency, because once you are doing FFT, why you are doing FFT on this signal? To know which frequency component is present and what is the magnitude of the frequency. Okay, so how do you know? Forget about that. So if this is the FFT, this must correspond to 50 hertz.
Okay.
And of magnitude 1, because you look into your signal. What is the maximum magnitude of the signal? Magnitude is 1. What is the frequency of the signal? 50. So while interpreting this result, you should interpret that this result is corresponding to a signal whose frequency is 50 hertz and whose magnitude is 1. But nobody is able to interpret. So the interpretation is very easy. What is your sampling frequency you have chosen?
64.
64 into 50. How many points you are taking in analyzing window?
64.
64. So the frequency resolution is fs divided by number of points. So what is your fs?
64
into 50.
divided by
Number of points is 64. So your frequency resolution is 50. That indicates that it is k. K is a discrete domain. You are calculating what? Xk. So first point corresponds to x0. Second point corresponds to 1. So from these to this, one resolution. So this corresponds to DC. This corresponds to 50 hertz because your frequency resolution is 50 hertz. So see, same thing is coming or not? Okay. How to interpret the amplitude? The amplitude representation is the number of points you are taking divided by 2 corresponds to unit amplitude. How many points you are taking? 64. Divided by 2, 32. That means 32 must be 1. See where it is coming? 32. Is your interpretation okay? नहीं आप समझ गए सर क्या बोलेंगे? Let us take the other one. Same signal, 50 hertz. Same sampling frequency, 3.2 kilohertz. But I have extended the signal up to 2 cycles. So if I have extended to 2 cycles, how many points I have? 128 points for FFT. So if I am calculating FFT of this 120 point, it will give me up to 64 points. So this is my FFT. Let us interpret. So what is frequency resolution? 64 into 50 divided by 128, 25 hertz. 0 corresponds to DC, 1 corresponds to 25, 2 corresponds to 50. So this should come in 2. But in MATLAB plotting 0 तो नहीं आएगा ना? It will come in 3. This corresponds to DC, 0. This corresponds to 25 hertz because your frequency resolution is 25 hertz. This corresponds to 50. See the magnitude. What should be the magnitude factor? You are taking 128 points. So magnitude factor is 64. 64 is equivalent to 1. Where you are getting? 64. Interpretation is correct. Both the signal are same sampling frequency, but it depends on how many points you are taking for the analysis. So that's the point. While analyzing the FFT, you must give stress. कि क्या ये क्या दे रहा है? Clear? So now you have got the frequency resolution idea. Yes. So frequency for better resolution, what do you want? More number of points in the signal to be analyzed. For better frequency resolution, more number of signals points. So that's the point. Oh, another example. Here I have a fundamental and third harmonic of 0.2. That means I have 50 hertz and 150 hertz. 50 hertz magnitude is 1. 150 hertz magnitude is 0.2. This is a mixed signal. And how many points I am taking in the signal? 10 cycles, 640 points. Okay. So without looking into this, now you can tell it. Where you should go get your fundamental and where you should get your fundamental is 11. Third harmonic where you will get? Third harmonic, here you have another frequency is 150. What is your frequency resolution? If I am taking 640 points, 64 into 50 by 640, that is 5 hertz. So 50 hertz where it will come? 150 divided by 5, 30 plus 1. Where it is coming?
31.
31. Okay. Magnitude 0.2, how you know? What is 1? 320 is 1. Because you are taking 640 points. So if 320 is 1, 0.2 corresponds to 64. So see its magnitude. 64. Okay? So your frequency FFT interpretation is, I think, now strong enough to interpret this one. Same. Here, I have a signal fundamental, third harmonic, but another 5 Hz signal. That means in this signal, this is a mixed signal. I have 50 Hz, I have 150 Hz, and another signal of 5 Hz. Sampling frequency is constant, 3.2 kHz, 64 into 50. I am taking now 5 cycles for analysis. So if I am taking 5 cycles for analysis, what is the frequency resolution?
64
into 50 divided by 64 into 5. 5 cycles means 64 into 5. So frequency resolution is 10 Hz. So now when you are applying FFT in this case, now you see, where should you get fundamental? Fundamental 50 Hz, where you will get? 50 by 10 plus 1, 6. So 6 corresponds to fundamental. What should be its magnitude? 320 by 2, 160. So that is coming perfect. 160, no problem. Where third harmonic should come? 150 divided by 10, that is 15 plus 1, that is 60. And its magnitude will be 164 corresponds to 1.2 divided by 5, so it is around 32 or something. Okay? But can you get the information of the 5 Hz signal? Because your signal contains a 5 Hz. Okay? Your signal contains 5 Hz. But the sampling frequency which you have chosen and the number of points you are taking for analysis, be clear here. You are choosing a sampling frequency 64 into 50, but the number of points in the signal for analysis purpose you are taking only 5. So your frequency resolution is 10 Hz. You won't get any information of 5 Hz there. Because your first corresponds to DC, second one corresponds to 10 Hz. So 5 Hz is not there. So there what we will get? Some aliasing effect, which we have discussed earlier. Because 5 Hz cannot be retrieved from this signal. So now you see, as if my signal is giving. So here this corresponds to DC. This corresponds to 10 Hz. Because my frequency resolution is 10 Hz. This corresponds. So as if it is giving some 10 Hz component present and some DC component is present. No 5 Hz component present. Why? Why this is giving like that? Because the number of points you are taking for analysis and the sampling frequency you have chosen, there the frequency resolution is 10 Hz. Although your signal is having some 5 Hz signal, you are not getting the information on that. But now, with same sampling frequency, with same signal fundamental, third and 5 Hz, if I take 10 cycles of the signal, then what will happen? My frequency resolution becomes 5 Hz. So I can exactly extract the 5 Hz component. So that's why that is a very important concept. Till now whatever we have discussed, the observation is keeping the sampling frequency constant. If more number of cycles to be taken in the data will go for analyzed, or length of the data analyzed is more, then the better is the frequency resolution. Are you clear this simple concept? Although it looks very simple, but the understanding is much more important for analyzing the practical result. If you are doing some practical work, either designing a controller or designing whatever PowerPoint study, so you don't blindly do this FFT analysis. Next, we will go for. Okay, so now at least you got the idea of this Fourier transform. Next is subtype Fourier transform. Just one thing I will tell you before going to subtype Fourier transform. Okay, now this is my signal. This is my signal. How many cycles of the signal I have taken? 3 cycles. See, for the first cycle you your 50 Hz component. For the second cycle, you have 50 Hz plus some harmony. For third cycle, it is again 50 Hz. If you take a 50, what information you are getting? Because you see, in FFT, what is doing? FFT has taking your signal, it is generating another sine or cosine of the same length as that of the signal. The signal length must be equal to your window length, thus e to the power minus j 2 pi ft. Okay, so now if you are generating a sine fundamental of this box, so you will get fundamental. Now let us, here you have during this cycle first and third. So for third harmonic, what you are doing? You are generating another signal of third harmonic. So when you generate a third harmonic signal, what will happen? Now this is 1, this is 1, this is 1. Like, okay. Now it will take product. Here only this portion, it will give a maximum value. In the other portion, you want, because I already have told you that if this is your fundamental and you generate a third harmonic of a second harmonic, let us this, then you are not getting this value. So now when you take FFT of this particular signal, it will give you, yes, your fundamental is present and third harmonic is present. Okay? Okay. So now let us take a signal of this. Please try to understand the philosophy of this. One. How many cycles of the signal I have? 3. Here, one cycle, first cycle and second cycle are fundamental, but third cycle having fundamental and harmonic. If you take FFT, you will get the same FFT or different FFT. You will get the same FFT. Because what FFT does, you are multiplying that signal with a sine and cosine and taking the summation over the whole. So when you are multiplying with a third 3 times of f window, during that portion third is there, that will be multiplied only and the summation will give the same value. The others will give you 0. Because just I have already told you and mentioned you, now let us say you have a signal of this. So if you are multiplying with second harmonic, if you don't have any second harmonic, it will give you a 0. But if you have a second harmonic during this cycle, you will get some value. So now the question is whether your third harmonic is present during the second cycle,
or
as long as the duration is fixed, or third cycle, or first cycle, you are getting the same FFT value. If you calculate the Fourier transform, you are getting the same information. Now what is the drawback of FFT?
we cannot identify which cycle.
So FFT although gives you the information of what frequency components of what magnitude is present, but it doesn't give you any time information. At what time those frequency components are present. It will look into the signal throughout, as if it will tell you the third harmonic is present throughout the signal. So no time information is there. So the FFT is not a suitable tool for the analysis of non-stationary signal. You have 2 types of signal. One is stationary. Stationary means which frequency component doesn't change with time, and another is non-stationary signal. So nowadays any signal, either power signal, AC signal are non-stationary in nature. Okay? So to avoid this, what is the technique? That is the short time Fourier transform. So now what happens in a short time transform, Fourier transform? Because rather than going to mathematics, I will just give you idea. Suppose now in Fourier transform, what you are doing? You are looking the signal. First you take the number of cycles, 10 cycles, 5 cycles, 2 cycles, and you are looking the signal through the larger window. Instead of that, I now look into the signal through a narrow window or small window. So now equation you have the harmonic component, at least you are getting a time information. So that is the mathematics. Now there is no problem. xt is your signal and you are sliding a window. So how you will slide in mathematics?
Multiplying it with
ut is a unit step function. If you write ut minus t, then unit step function starts at t. It is slided by a time period t. So that is the sliding out there. So this is xt, then g is a window of t minus tau. Okay, and 8 is given either sinusoidal or something. Because this window of different type of Hamming window, Henning window, that we will discuss later on. So this is the fundamental concept of the STMT. Main difference is instead of looking into the signal through the same window as that of the length of the signal, you look the signal through narrow window, then slide the window, so that at least you will get the time information. One simple example here I have given to you. Now see, if this is your signal and this is your window, you see the first one is a window. Okay, that is slided to here or slided to there. So when you slide, so gradually these are the information you are getting from that particular signal at different instant of time. Okay. Now this is a signal having one frequency 500 Hz, another frequency 15 Hz superimposed with each other. But there are two impulses. जैसे कि हमारा ECG checkup suppose you are doing. Suddenly you will see it is following a particular pattern and sometimes it may jump to a high angle. So even if in power signal when switching operation has been done, there is a large transient or impulse or notch. So there are now two notches or two impulses at 125 millisecond and 130 millisecond. But is it visible two notches? No signal. See figure 1. Are there two impulses in 125 millisecond and 130 millisecond? One is visible clearly to you or not? This one? This one? Another notch is there present 125 millisecond, but it is in the negative direction. So that's why from plus 100, if it is goes to minus 50, so it is not visible there. But there are two disturbances or two impulses. Now, first thing I am doing effecting. If you are doing effecting, now see what is the information? What frequency components you are getting? 500 Hz and 1000 Hz. But are you getting any information of these two impulses? No. Why? Because FFT doesn't give you the small disturbances which are present in the signal. Because you are looking to the signal through a larger. Okay. So let us see. In MATLAB there is a command, simple command, spectgram, SPECGRAM, to calculate the short time Fourier transform. So now I am calculating the short time Fourier transform of the signal with a window, taking a window of 8 milliseconds. Do you know why I have taken 8 milliseconds? Tell me once. You have a signal of 1500 Hz. Okay, so if you are taking what is 1500 Hz time period? 1 by 1500. Okay, so if you are taking a window width of 8 millisecond, that means up to 8 millisecond you take a window. So in that 8 millisecond, you will get the information 1500 आ जाएगा या नहीं आएगा? Because the time period of 1500, suppose the time period of 1000 Hz is 1 millisecond. Right? So the time period of 500 Hz is 2 millisecond. So in your signal you have 500 Hz whose time period is 2 millisecond. You have 1500 Hz whose time period is less than 1 millisecond. So at least if you are taking a window of 8 millisecond, so 500 Hz signal, how many will come? 4 seconds. And this 1500 Hz may come 10 seconds. So sufficient enough oversampling time is there because the window length you are taking is more than the twice of that. So now you see, if I am applying the STFT. So in STFT there should have many information. In FFT how many information is there? Frequency, magnitude of the frequency. Here what information you will get? Time, frequency, magnitude. So either you can plot it in a 2-dimensional contour plot or you can plot it in a 3-dimensional plot. So this is a 2-dimensional plot where this axis axis is your time axis, x axis is your time, y axis is your frequency. Okay, this y axis is your frequency, and the color whichever given, this corresponds to magnitude. Okay, because you have to plot a color bar in MATLAB, or it is a 3-dimensional color. Now the question is, are you getting better frequency information or not? See the frequency band. This one corresponds to 500 लिखा है, this one corresponds to 1000. What is this? ये जो दोनों. Where are your disturbance? 125 and 130. But is it clearly distinguished? It is not clearly distinguished by choosing a window width of 8 milliseconds. Now what I am doing? See, just compare these two, and I will ask a question. Now I am taking a window width of 2.5 milliseconds. So if I am taking a window width of 2.5 milliseconds, your 1000 hertz component, how many cycles will come? Only 1.5 cycle, because it's 1000 hertz is 1 millisecond. If I am taking 2.5 milliseconds, only 2.5 cycles will come, and 1500 maybe 4 cycle or 5 cycle. So earlier, remember your FFT. The more number of cycles you are taking, the better is the frequency resolution. But the less number of cycles you are taking, the lower is the frequency resolution. So if you compare just the previous result, see, more number, you are taken a window of 8 milliseconds. That means more number of cycles of the signal you have taken. So you are getting a better frequency information. Now when I am just reducing the window length, what I am getting? I am getting a poorer frequency resolution. Just to compare the two red strips at 500 and 1000, the frequency resolution in earlier case with a larger window and the present case with a smaller window. But what you are getting better?
Disturbance.
The two disturbances is clearly visible at 125 and 130 milliseconds. Are you clear? So now what is your general idea? The point is, the larger will be the window, the better is the frequency information you can extract from the signal. But the poorer will be the time information. The smaller will be the window, the better will be the time information, but the poorer will be the frequency information. So always the signal analysis people do a time frequency analysis. So any signal can be analyzed by a time analysis. Time analysis is nothing but your RMS value, maximum value, AO. Frequency analysis is your FFT. Then frequency and time analysis or time frequency analysis is your STFT. Are you clear? So in the short time Fourier transform, you can get the information of STFT. One simple example will tell you. So this is the trade-off, because the larger the window, better is the frequency resolution. The smaller the window, the better is the time information. But how will you choose? Because your signal is unknown to you. You don't know what frequencies are present. You don't know where is the disturbance is present. Are you clear my point? So how to choose? Now suppose, take this example. Just I am modifying a signal a little bit. Is it the same or not? How many normal cycles you have? 2. But the third harmony, which was starting here after the end of first cycle, which is started here at the end of second cycle, now it is started at half of the cycle. So if we take one cycle window width earlier as I have told, if we take one cycle, now as if in the first cycle your third harmony is present. When you slide it by one, as if
Second also.
so the more with the window length, the less will be the time information. So instead of full cycle, you will take a half cycle window. If I take a half cycle window like this, so here fundamental, here third harmonic, here third harmonic, here fundamental. So let's see what will happen. The less window you are coming, the better you are analyzing the time information. At what time the disturbance is there. So the disadvantage of the STFT is that your window width is fixed, or the user will define. You have to define what is your window width. And how will you define unless you know what is the nature of your signal? So that is the demerit. Choosing a proper window width in the case of STFT is a challenge, because you don't know what is the nature of your signal. So how should you change what is the window width? So here one simple example I generally give in every classes simple thing. If you look into the outside, now I will just compare the Fourier transforms or time Fourier transform. If you look into the outside, what you are observing? बाहर देखो क्या दिखाई दे रहा है? Tree है ना रास्ता में नहीं है? So there are beautiful trees out there, isn't it? If you look into the color of the leaves, what is the color of the leaves? Green. Suppose a parrot is sitting on that tree. Can you find it here?
No.
I'll tell you find that parrot. Huh? You know. So how will you attempt to find? How will you attempt that to find that parrot there? So the thing is, you are sitting in this room. So first you open all the window and try to look into that. Try to look into that. So what you are observing? There is a signal, pure sinusoidal signal. That is the color of the trees. But there is a small disturbance in parrot. Unfortunately, the parrot color and the tree color are same. So when you are opening all the window, that means you are looking the signal through Fourier transform. So you are getting better frequency information. सब green दिखाई दे रहा है. But the time information parrot is missing. Then हम रास्ते में आ रहे थे, 10 रुपया बाइनोकुलर मिल गया. Let us 10 रुपया बाइनोकुलर मिलता है ना? Okay, cost is low. You go to, so if you use that, you go to the one corner of the window. Earlier you have opened the whole window. Fourier transform, sine or cosine extends from minus infinity to infinity. Energy is not compact. Sine का energy क्या है? 1. Whether you take 10 cycle, 50 cycle, 100 cycle, 1000 cycle, energy is always 1 side का. ठीक है? So now in this binocular you go to one end, just look into that. दिखाई नहीं दे रहा है. Then slide till the end. That is your STM theory. You may or may not find. But आजकल तो जमाना बदल गया ना. Nobody in our IIT Delhi, I have not seen calculating by means of the calculator. So mobile में calculation कर रहे हैं. Okay. So now suppose you have given a beautiful zoom camera. तो क्या करो? You go to one end, just see there. Then your camera there is provision 1x, 2x, 3x, 5x. So when you will rotate that way, as if the picture is coming closer to you with a magnification. In the earlier case, you have only translation. You are sliding the window. Now at one position, you dilate. Dialysis करते हैं ना बॉडी को. You dilate. Dilate means magnify the picture coming to you. वहाँ parrot नहीं मिला. Then translate. Again dilate. Then translate. Then what will happen? Ultimately, you will be able to find the parrot. Because now you are looking through a window. The window which doesn't have only the translation facility, but have the dilation facility. That is wavelet transform. Clear? That is wavelet transform. And why it is known as wavelet? हम बोलते हैं क्यों wavelet? What is a wave? What is a wave? A wave starts in sea. From where it starts, where it ends, you don't know. Wave. What is a book? A volume of this. What is a booklet? छोटा सा. So if you will give a booklet, means all information in a compact support. अरे आपको कोई देगा जो बेचते हैं ना ऑसिलोस्कोप ये इतना बड़ा बुक लेके देगा तो क्या करोगे? डस्टबिन में फेंक दोगे ना? कौन पढ़ता है इसको? To get the information. But if it is a colorful leaflet having all the information in compact support, okay, a leaflet, that is a wavelet. So wavelet is a smaller version of the wave having all the energy concentrated in a small place. जो साइन का एनर्जी यहाँ से लेके वहाँ से infinite है. So that is a wavelet. We will go to wavelet after the T, perhaps T has come. Thank you.